Suppose that a car starts from rest at constant acceleration of 2.0 meters per second. So we have some car and it's moving down this road. We'll call this car A, and it's starting from rest, so V0, comma A is equal to 0. So the 0 here just means that it's the initial velocity, and A means that it corresponds to car A. And then this car also has some acceleration, so let me move this down a bit. This car also has some acceleration, and it has some acceleration A, sub A, and that's equal to 2 meters per second squared. Okay, and the velocity has units of meters per second. Great. Now, there's another car, which is a truck. So we'll move this down a bit, and we'll kind of have this be a three-dimensional road. And at some other point, at the same time, there's a truck. So I'm going to try to draw a truck here. There we go. We'll call that truck B. And at the same instant, so these are at the same position. At the same instant, a truck traveling, so it's been traveling, right? So this truck has been traveling. And this guy here, car A, starts from rest. But this truck B has been moving. And at this moment, when they both cross this line, this truck is moving with a constant speed. So V0, we'll just call it V because it's a constant speed. And that speed of B, the truck B, is equal to 10 meters per second. And it overtakes and it passes the car. And the reason for that is that this guy starts from rest, so his initial velocity is 0, and the truck zooms by him. So in part A, this question asks us, how far beyond the starting point will the car overtake the truck? Okay, well, to start, when the car finally overtakes the truck, so for part A, this occurs when delta D sub A is equal to delta D sub B. And remember that delta D is equal to V naught times T plus 1/2 times A times T squared. We can now write what are delta D sub A and delta D sub B for the car and the truck. So delta D sub A, remember that V naught A is equal to 0, right? That's what we said right here. So this first term, V naught T, is 0, right? So the only term that survives is the acceleration term. So this guy for car A is equal to 1/2 times A sub A times T squared. But we know what A sub A is. It's 2 meters per second squared. So this guy is equal to 1/2 times 2 times T squared. And that's just equal to T squared. Okay? And then for delta D sub B, this is equal to, well, if we look up here, we're given a constant velocity, B, right? It says it's a constant speed that the truck travels at. What that means is that A sub B is equal to 0 because the acceleration is the change in velocity over time, or the derivative of velocity with respect to time. And since velocity is constant, acceleration is 0 meters per second squared. So for delta D sub B, in this equation here, the second term is 0. So this guy is going to be V naught, comma, B times T. But remember that the velocity is constant. So V naught sub B is the same as VB. It's the same everywhere. So this is going to be equal to 10 T. Okay, then what we see is when we equate these two guys to each other, so we say that delta d sub a is equal to delta d sub b. And then when we plug in for the two delta d's above, we see that t squared is equal to 10t. Okay, now what we see is that there's a t on either side that we can cancel, right? So we can actually get rid of that t. We get rid of one of those t's. So we see that t is equal to 10 seconds. Okay, that's not exactly what we wanted, right? Because this thing says, how far beyond the starting point will the car overtake the truck? Well, we know that it occurs at 10 seconds, right? So we can just plug in 10 seconds to either one of these equations, because at that time, the displacement or the distance traveled by the two cars will be equal to each other, because that's what we've demanded here, right? So we said we're setting the two distances equal to each other. That's fine, right? And then we say, okay, that means t squared, which is the distance traveled by car A, that's equal to 10t, which is the distance traveled by truck B. And then we say, okay, well, there's a t on either side, so get rid of that. And then we get a unique time value. So we find that these cars have to coincide after they started moving at t is equal to 10 seconds. So what this means then is that, let's say, okay, delta d sub a at time t is equal to 10 seconds. Let's plug in. That's equal to, well, delta d is 10 t squared, so that's equal to 10 squared, which is equal to 100 meters. And just to double check that we've done our math correctly, let's calculate delta d sub b, or the displacement of the truck at t is equal to 10 seconds. And that's equal to 10 times t, which is 10. And that's, again, equal to 100 meters, as we expected. Right? So what this means in our picture is that this car here, this truck, is zooming by, right? And then the car kind of slowly speeds up, and then boom. At this point here, let's say, the truck is speeding along. So maybe, yeah, the truck is speeding along here. And then finally, just at this blue line here, the car A catches up. And then after this line, car A is ahead of truck B. Okay, so the answer to question A of how far beyond the starting point will the car overtake the truck, that occurs at 100 meters past the starting point. Okay. Now, for part B, we see that it asks, after what time will this happen? So after what time do these two cars catch up to each other? Well, I mean, we already calculated that time, right? It's literally t is equal to 10 seconds. So we actually, in answering this problem, we found that the answer here is t is equal to 10 seconds. These two things coincide with each other, or they have the same distance past the starting point at t is equal to 10 seconds. So that's pretty easy, right? In solving the first part, we actually also secretly solved the second part. And then the last part is at the instant that these two cars coincide in the distance. So at this line B, at this second line, we'll call this 2. At 2, at this blue line 2, what is the speed of the car? Okay, well, we know that the initial speed of the car is 0 meters per second. And we know that it accelerates at 2 meters per second squared. So, since that acceleration is constant, we have an equation that we can use. And that equation, I'll move down here. That equation, remember, is the velocity at time t for an object that's accelerating is equal to the initial velocity plus the acceleration times time. And that's assuming that acceleration is constant. So assuming constant acceleration. Okay? Now, for us, for car A, we want VA, and it said, let's see, it said at that instant. So that means at time t is equal to 10 seconds, because we already found these cars, the car A passes truck B at t is equal to 10 seconds. So we want to calculate the velocity of car A at t is equal to 10 seconds. So that's equal to v0, comma a plus a sub a times 10. Okay, now let's go back up to our diagram, and we see that v naught a is 0. Well, that's easy. And a sub a is equal to 2. So plugging in, this is the initial velocity is 0, plus the acceleration of car A, which is 2 times 10. And 10, remember, is the time. It's the time at which these cars pass each other. So the velocity of the car at 10 seconds when they pass each other is 20 meters per second. And that is the answer to part C of this problem. Thank you.